As far as administration with SQL Server Analysis Services 2016, the new part is the scripting language. The data model is now defined in a JSON structured language. This is much easier to read as a script and then modify or create from scratch, enabling third-party tools. This enables tools to compare the versions and get the differences, which was not easily able to be done with XML. Actually, the source control can be posted this JSON script and can be used as the design and compare between versions. It's called Tabular Model Scripting Language, and it's a command and object definition syntax for analysis services tabular models, only with compatibility 1200 or higher. Its acronym is TMLSL, and it communicates to analysis services through the normal XMLA protocol, where the XMLA execute method accepts both JSON scripts and the traditional XML-based scripts. This is delayed third-party scripting languages like BIML to implement. I questioned this a while back to some of the BIML developers, and they knew that this was going to change in analysis services, so it delayed a lot of third-party tools. The key elements are metadata-based semantics. The model is composed of tables, columns, and/or relationships. Equivalent objects in TMSL are table, columns, relationships, and so forth. The new metadata engine supports these definitions. No more XML, with the exception of payload that is formatted in either JSON or XML, or both TMSL and ASSL language that you might be already familiar with. This functionality equivalent is how the providers can use commands and metadata with the XML methods to do server communication and data transfer. Another big deal is the Database Consistency Checker, or DBCC, and if you're a DBA, you know about this. It runs internally to detect potential data corruption issues on the database load, but it can also be run on demand if you expect problems in your data or model. This DBCC command runs different checks depending on whether the model is tabular or multidimensional. Another big deal is parallel processing. This release includes new parallel processing functionality for tables with either 2 or more partitions. It increases the performance of the processing. Since there are no more configuration settings for this feature, and you can learn more about it when configuring the partition or processing tables. DAX functions have been added to SQL Server Analysis Services in 2016 and SB1. The big ones are the calendar functions, and this first one returns a table with a single column named date, and it contains a sequence of dates based on the start and end date provided. It's very helpful for using dates without having to generate a date dimension for a specific range. It's not here to replace the dim date dimension table. It's only so you can use it in certain calculate type functions of a certain range of dates. There's also the calendar auto, which basically acts the same way as calendar, but the range is based on an existing date dimension in the model with one of its attributes. So it can be dynamically based on a filter context based on the existing date dimension. Another one, a nice one to have, is date diff, which counts the number of X between two dates. So it could be days, seconds, minutes, hours, months, quarters, or years. That interval parameter is where you specify the X. This is a big deal, especially for performance. Before, this had to be added in the T-SQL, which made some of the processing slower. Another big deal are math and trigonometry. With all the analytics going on, these functions include variations of sine, cosine, and tangent. plus a combination of ceiling and rounding functions. Go to the MSDN for a full list of all these definitions. Of course, this leads us to the statistical functions like geomean, confidence, beta, chi-squared. There's also a percentile and median statistic functions. And if you look to your right, the others, group by, intersect, and so forth, are all there to help improve the performance of DAX. So your DAX functions are guided by the developers looking for things, but more so with the performance that replaces the T-SQL needed to put the stuff in memory. So what other improvements are there with the DAX functionality? Well, variables have been added to DAX, and you can use this in your query or even a measure, and it helps evaluate an expression once. Then you can use that results many times without having to duplicate that logic. This reduces development time, expression execution, as well as testing. The if switch is also a new strict evaluation. A branch which condition is false will no longer result in storage engine queries. Previously, these branches, according to Microsoft, were eagerly evaluated, but the results discarded later on. Microsoft also says that group sets are added when a query asks for measures at multiple granularities, like total, year, and/or month. A single query is sent at the lowest level. The results of the granularities are then derived to the upper levels. This reduces time of sending multiple T-SQL statements for multiple expressions when it is executed. Join orders, according to Microsoft, improves the way that you arrange of join orders so that the joins start with the most restrictive intermediate table that correlates with the other intermediate tables. And this follows the T-SQL query engine that tries to find the most restrictive to give you the best plan and the quickest returning of results. There's also a count row optimization, and it uses table heuristics to return the results. Storage engine cache has been improved, and now it caches per database instead of per server. So now the storage engine does a little better with the way it executes queries and uses its cache. We'll do some demonstrations of administrating and new DAX functions. We'll start by opening up SQL Server Data Tools for the Visual Studio 2015 shell that it uses, and we'll open up our project that we've already had deployed. This one can be followed along in previous demonstrations in these sessions. We'll open up the model BIM file, and once it's open, we're going to go to the Internet Sales Fact Table. When we go to the Internet Sales Fact Table, we'll see towards the end, let's give ourselves a little more room here. See towards the end there's some date tables. We'll go to the model, process all in order to retrieve the data. This model is not told to be restored, so we have to do that ourselves. So we can type equals date diff. The first is the date that you want to start from. Let's say order date. Second one, let's say is ship date. And our interval is going to be days. So now what we can do in a table is get the difference between two particular dates to store as a computed column and then as well as a measure. So we can do a sum, an average, whatever we feel what's needed inside of the client tool to display for those particular things. So that's the date diff as a calculated column and also as a measure. The next thing we'll look at is the parallel processing. So if we go to model, process, there's process partitions, process table, or process all. The table internet sales is actually a combination of multiple years. So we could actually go into the definition of the table, source, and edit, and we could see the particular table query that's used. If we want to partition it, we can go to table, partitions, and we can start creating partitions of this table. So what I'm going to do is I'm just going to create two partitions here. The first one I'm going to say is new, and then I'm going to copy this one and call the copy old. And what I'm going to do is go to those partitions again. I got an old and a new, and I could actually look at the SQL. What I want here is that order date. So I'm going to say where order date is less than, let's say 2014 12/31, and I can validate this just to make sure it's a valid statement. If I click OK and go back to the table partitions, what I want is that same logic but greater than or equal to. That's what I put in the old, the new. So what I want to do is say equal or greater than. All right, it's going to be greater than or equal. Validate is nice to have. I'm going to click on old, go back to the query, and put that same where clause in where it's less than. I'm going to validate it. Click on my little table, process the changes, and you'll see this is the old data, which had 2013, and this should be the newer particular data. So I'm going to click OK. There's my two partitions. And I'm going to go to the table, model, process, partitions. So I have two partitions now, and I could pick the development to either do one or the other. But what's improved in performance now is that since I have two partitions and I click OK to process them, it's actually spawning them into two different exports now. And you can see they completed almost at the exact same time with the number of rows processed. So now in the performance, it has the ability to use multiple threads for processing. So you can imagine if you have 10, 15 years of data and multiple partitions, you can actually process that in different areas and get better improvements in performance. So this leads us to the last thing, which is inside of our management studio, we're connected to our SQL Server Analysis Services instances. And if I drill into that and refresh the reports, you'll see the one that's in memory right now is development, and the one that has been deployed. That part of that processing, I can go to that internet sales and say process table, and it'll highlight the table, and I could tell it what kind of processing to do. But if I script it out, what you'll see now is a JSON script, okay? This is different than the previous version. If I go to an older version, go to process database and script it, you'll see the old XMLA. So here's the difference in the compatibility of a 1200 or larger versus one that is in a lower like SQL Server 2012 or 2014. Because of Microsoft's cloud-first development, you're now seeing Azure Analysis Services. This is a display of our dashboard with an analysis services database created and then details about its properties. Now, if you're going to develop anything in the cloud, you're going to want some of the basic things of analysis services. And the Azure version does include direct query. So in Azure Analysis Services, if you connect directly to your data sources, you can have very close to real-time analytics inside of your cloud version of analysis services. You also have partitions, which is very important. If you're loading stuff in the cloud, if you can load it in partitions rather than all at once, it helps tremendously in speed of your ETL. The bigger deal is security, and row-level security as well as encryption is implemented in Azure Analysis Services. So now you can base your connection to row-level access to data. And since tabular is tables and rows instead of the multidimensional cube, which is tuples, you're now able to do the row-level security. Bidirectional relationships is inside of our Azure, as well as translations. You can try all this for free right now. If you go to azure.microsoft.com and in the services for analysis services, you can download a trial version, a 30-day free one. I'm going to display one real quick for you. And you can see here in my dashboard, I have an intro or LNO for analysis services. And I can double click that and bring up that particular instance of my analysis services. And what it's going to do is that's where I can stop and start these particular resources. So if I go look for my LNO, I can look that it is running and I can create a new model. If I click on new model, I've got to be able to select a date. I'll return back to it. And what you want to do is if you're actually using it in development and doing a trial, it is going to start to charge you if you leave it on. But if you click pause, what that does is it stops it from running. So as you develop, test, show it to your boss, and then you turn it off so it doesn't continuously charge you for usage inside of Azure. And you'll see this and you'll see warnings about this constantly. Multidimensional cubes has been changed inside of SQL Server Analysis Services 2016. The biggest point is the distinct count measure group, which has performance improvements. Your direct query to either Oracle and or Teradata, the T-SQL that is returned has been greatly improved. This helps with migration of non-SQL Server systems to using tabular rather than cubes. The multidimensional cube is more enterprise ready, but tabular is getting there. Another big deal with multidimensional was roll-up and its performance. So DB2, Oracle, and Teradata have been improved. While most enhancements in this release are specific to tabular, a number of enhancements has been added to the multidimensional models. For example, the roll-up optimization for data sources like DB2 and Oracle have been improved inside of this release. The next one is drill through with multi-selection support. This has been asked for probably since Analysis Services 2005 with queues. So now when you multi-select filters and you double click to drill through to see the results will be filtered by that multiple selection filter. This support has been added in SQL Server 2016. Another big deal is an Excel query performance. So when you're doing like direct query, or in the case of cubes, roll-up, T-SQL is generated in Excel. You can actually, with some add-ons, view this. Now, this is only going to be available in 2016, but if you look at an old and a new version, you'll see that the T-SQL behind the scenes has been optimized. That way, as you drill around and query, the performance of the T-SQL sent from roll-up will be greatly improved. This release includes PowerShell enhancements for tabular models, only with compatibility level 1200. You can use all of the applicable commandlets plus commandlets specific to tabular, like invoke-process AS database and invoke-process table commandlets. This lets you use PowerShell to process tabular models. You might be asking, why would I do this? Well, most data warehouses are updated nightly, and now you can automate PowerShell scripts to do most of the work. So what is invoke process AS database? This processes the operation of the database with a specific process type, like all, table, partition, or a refresh type, depending on the underlying metadata type. So you can just process the data, the index, or just the metadata. The process type property is for metadata, like tabular databases in compatibility 1050, 1100, 1103. You can limit the processing to just a table by invoking the process table. So for instance, your dimension tables might not change, but your fact table does. So your automation with your PowerShell script can invoke process table with a specific table name like fact internet sales, and only that will be processed. There's also a SSAS command commandlet for PowerShell. Invoking this invoke-as command now accepts the new tabular model scripting language, or TMSL commands. Other Analysis Services PowerShell commandlets may be updated in the future release to the new tabular metadata. Exceptions will be called out in the release notes at that time.